we have time for one more question. Okay, so it's kind of pixelated, but I will write it out so that you guys can see what the question says. Basically, it says, given the following series of acids arranged in order of decreasing acid strength, and then they say, is the following acid-base reaction favorable or unfavorable as written, left to right? So let me write down the series of acids in order of decreasing acid strength. So the strongest one is HCl. And then we have a carboxylic acid. And then next is just water. And then next is just your standard ROH. The next one is triple bonded carbon. And then H2. I'm running out of space, but I'll try to fit in. The next one is like an amine group, I think. And then the last one, which is the weakest, is just this CH group. Okay, so A is asking, is the following acid base reaction favorable or unfavorable? Just so we can all read it. Basically, the reaction looks like this, so even I'm kind of blind, but let's see. Of a lone pair there. And then it's gonna be plus CH3O, which looks like it has a negative charge. And then on this side, the alcohol is deprotonated plus CH3OH. Okay, so let's look at our series of acids. So I'll just write down that the carboxylic acid in this form is a stronger acid than the methanol. Okay, so oh, sorry. Where'd it go? Let me just reopen this. And it should. Okay, I don't know what happened there, but the carboxylic acid is a stronger acid than the methanol. So therefore, it will give a proton easily. So therefore, this reaction is favorable, going from left to right. Okay, so let's look at part B of this question. It says, which is the stronger acid, 1 or 2? See below. Okay, so let me write out these two options. So on the left, we have H2, nitrogen with a double lone pair, sorry. And it is with a methyl group. So this is option 1. Or we have another amine. It's bonded with a carbon. And then there's a double bond, CH2. And then this is option number 2. So it's asking, which is the stronger acid? So let's look at our two options. Option 1 has a lone pair, which can be used for donating. Donate lone pair. So this makes it a stronger base. And then if we look at our option number 2, there's also a lone pair, but you'll notice that it is in resonance with this double bond. So you can tell something's in resonance when it has a single bond in between the two. So I'm just going to write down that this lone pair is in resonance with the double bond. So therefore, it cannot donate its electrons. So this option will be more acidic. Okay, so the answer to part B is option 2. I'm just going to put a circle around it. And let's see what our junior tutor said. The double bonded carbon are all sp2 hybridized. They probably looked at a different question altogether. So I am going to just briefly write out what we just went over. So for part A, since